Hello everyone. So today we are solving these. We are trying to solve these five questions: coin piles, palindrome reorder, GUI code, Tower of Hanoi, and creating strings. Okay, so let's start with the first problem. Okay. Mm-hmm. I think I've solved a similar problem before. So Tower of Hanoi 2x plus y equal to a and x plus 2y equal to b. Sorry, coin balance. X plus 2y equal to b. So if we can find any x and y solution for this, we are good to go. We have to remove 2 from the left and 1 from the right, or 1 from the left and 2 from the right. So when we are removing 2 here, we have to remove only 1 here. So here 2x, here x. And when we are removing 1 here, have to remove 2 here. So y, 2y. So yeah, if we can find any answer for the solution, we are good to go. Let's see, the number of test cases are 10 power 5 and A can be how to find a solution for this. So as the number of test cases is 10 power 5, n log n solution can be used. So n log n. Fine. For every A and B, how to find x and y? Is there or not? X equal to b minus 2y. So 2 into b minus 2y plus y equal to a. 2b minus 3y equal to a. 2b minus a equal to 3y. 2b minus a by 3 equal to y. So we got y. Minus 2 into 2b minus a by 3. Hmm. 2a minus b by 3. So both 2b minus a and 2a minus b should be multiples of 3. Then we'll get a solution. Otherwise, x and y will be in half, not will not be integers. If they are not integers, we will not remove them, right? Yeah, got it. What is this coin piles? In B are integers in A. Let's take long just in case A, comma B. C in A, B. Temp1 equal to 2 into minus B. Log 2, 3 equal to 0 and sure, we have to print the answer also. We just have to print yes or no. Right? Yeah. 3, 2, 1, 2, 2, 3, 3. 3, 2, 1, 2, 2. Yes, no, yes. Yes, we're good to go. I think I solved the same similar kind of problem in maybe TLA Eliminator, CP31 sheet, or some brute forces contest. I don't remember exactly, but yeah. Oh, damn. Mm-mm. Yeah, I just missed this case. When people told cses make you think very nicely. Both A and B can be zero. Both A and B cannot be zero. So, the lesson I've learned with this is even though the problem seems similar, you shouldn't submit fast without going through everything. Penalty matters in ICPC, man. Now it's time to seriously think about the answer. Both are not zero. Later, after some point, one became zero. How? 2b by 3 should be, this should be positive and this should be positive, or zero. This only I'll do every time. I accept it. This only a way of doing just like that. 100 is not this now. Even though you see a problem that you solved before, the same similar kind of problem, don't jump into conclusions too early, ma. Yeah, that's so dangerous. Given a string, your task is to reorder its letters in such a way that it becomes a palindrome. Okay. Mm-hmm. Okay. Palindrome reorder. N can be 10 power 6. So n log n solution works. So, so, so. How to reorder? A, B. 1, 2, 3, 4. This is a 3, this is a 3. Then how, Ray? Not happening. So every number should come in even except one number. A to Z only there. So it's easy. Every number should have even number of occurrences except one number. Yeah. So if there are more than one without even number of occurrences, then it's done. So big of n traversal to get, and then big of 26 again. Okay. We'll be knowing whether if doesn't have any solution, and then reorder. Reorder. If we have found only one and only one which has this, put that push front, push back. These two where we have title. Push front, push back. We need to have both the functions. Then that would become so easy, so elegant, just looking like a wow. Or else we do this now. We create a string. We create an array of characters of the same size, n, and then if there is a single character, we push in n by 2, we push in the middle. So 0, 1, 2, 3, 4, 5 now. 6 n by 2. Okay. Remaining we push here, 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 like that we go. Okay, got it. I think I solved similar kind of problem before also. Same similar kind of problem. I don't know, but this okay. Palindrome reorder dot just don't need this. We'll just get a string, right? String s. Let's have a doubt. How long can a string be? How many characters can a string in CBV have? Same kind of doubts. Similar. Environment memory maximum value. These many characters. Visibly, that is so. Okay, fine. Compiler restraints and all that. We'll just check all this. अरे यार, where is my mind? Shit. I'm sorry. Charge. Flappy charge. Flappy charge. Laptop. Charge, 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 charge. Laptop charge. Laptop charge, laptop charge, laptop charge, laptop charge, laptop charge, we need laptop charge, laptop charge. Yes, let's go. अच्युतं केशवं कृष्णदामोदरं रामनाम. This internet na bro. Internet, where are you going? Hello. Zero streamers. Okay, it's okay. It's okay. You ask me why am I doing live stream? Because see, I just want to do it because I've been so inconsistent. So I'm just doing this for myself, to be honest. So that at least I'll be consistent. I'll solve problems without any recognition or anything. Having the motivation is so tough. So I'm at least maintaining discipline because maybe discipline beats motivation. Who knows? Let me try just this loaded. Yeah. Grey code. Come on. A gray code is a list of all 2 power and bit strings of length n where any two successive strings differ in exactly 1 bit. Yeah, all 2 power n bits of that is the Hamming distance as 1. Your task is to create a gray code for a given length n. Your task is to create a gray code for a given length. Oh, damn! Gray code create. And is less than 16 2 power. Mommy. Great, good. Okay. Okay. All zeros. Then last all one's name. Let's take an I and make it one. Next one and make it one. And then again next one and make it 0. And again next one. Yeah, I remember this trick for Greek code. 0 1 1 0 ऊपर 0 0 नीचे 1 1. Yeah, and then this mirror. Yeah, I remember this mirror trick for Greek codes. ऊपर all 0 0 नीचे all 1 1. This trick. Wait, do you know this trick? Mirror trick. Is it visible? Ding ding ding. Maybe. I don't have this virtual board print. Yeah, I remember this method. How to write that. Cool. Yeah. ऊपर half 0 नीचे half 1, right? So let's follow that. 2 power 16. I mean 2 power n half of it ऊपर of 0 नीचे of 1 and then in these half of it ऊपर of 0 and नीचे of 1 and this half of it ऊपर of 0 and नीचे of 1. But see, 2 power 16. What does 2 power 16? Let's calculate 2 power 16. 2 power 16. Mm. 65536. So we can have these many vectors of size 16. Yeah, it is possible. Let's do this. But yeah, maybe to teach recursion. This problem. Okay. This problem is. I am assuming this is to teach recursion and there is nothing in this. Let's check video later to find what this is. What more is this teaching? I have to create one more. So vector and answer. Yeah, answer 2 power n gamma vector int n gamma n. Yeah. Power n. This is XOR symbol. Power 2 comma n. My dot h is hopefully there in that. Does bits have mad dot h? Does bits library have mad dot h? Does not include. Okay. This is not a primitive function. Power. Let's go. Let's calculate this. Power of 2 comma n. Yeah. And fill answer start end. Let's keep this int start equal to 0 int n equal to 10 minus 1 void fill vector int and answer. We're passing the reference because this is huge. In start command and mid equal to start plus end minus dot plus 1 0 3 1 2 3 3 plus 1 4 by 2 2 0 plus 2 equal to 2 minus 1 mid int index. This index is 0 for int I equal to start I less than mid no need of minus 1 mid I is and this is not needed. Mid answer of index equal to 1 fill answer start mid minus 1 index plus 1 fill answer mid and index plus 1. Yeah. So n into 2 power n into power n. Yeah. Fine works. Two four and every going to power n to power n into n time complexity. Big of n into 2 power n space complexity. Big of 2 power n into n same. What happened, Ray? Let's do for 2 now. What happened? Reference size type long. Math.h also to know. What? Let's use temp here. End equal to temp minus 1 start and index is 0. Acha. Okay. If index greater than equal to answer 0 dot size return wrong. Yeah. Ending not there, re Bangaram. Acha, 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 acha. For int I equal to 0, else 1 chunk I plus plus. For int g equal to 0, g less than n g plus plus c out answer of I g c out ding ding ding. Gopala Gopala Anikidaram. Hare Re Baba. Mm-mm. Reverse Pullingham. Reverse, reverse, reverse. Zero. One. If it is equal to 0, this one. Else. I equal to Gopala Gopala Anikidaram. Yo, let's go, let's go, let's go. I just think this is to teach you recursion. 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 Hello, let's go over the fourth question. The time 46 minutes. I know these problems, the problems that I'm doing right now, all kind of feel familiar to me. Otherwise, that would take a lot of time to come through. Mm, Left stack, middle stack. In these five problems, I just want one hard problem that should almost make me cry. That's the maza, right? And then I think you feel this is it. Mummy, 1 minute. And then we have three stacks left, middle, and right. And then round discs of different sizes. Okay, we have a stack and then round discs of different sizes. Initially, the left stack has all the discs in increasing order of size from top to bottom. Okay, The goal is to move all the disks to the right stack using the middle stack. On each move, you can move the uppermost disk from a stack to another. In addition, it is not allowed to place a larger disk on a smaller disk. Okay. The task is to find a solution that minimizes the number of moves. Okay. To place a larger disk on a smaller disk. Okay, in the increasing order of size from top to bottom. Acha, top to bottom increasing size. So top we have the smaller one. So we put the smaller one here and we want to move all this from left to right using the middle one. And we can't put, okay, this one we put here and then we shift it to here and then we shift big one will get the here and then we put the small one here and we again put the small one back. You put the big one. Okay. Okay, first we put the small one on this. Okay. Okay, small one on right. And then we put the large one here. We put the small one back. Put the large one over here. And then now the picture is like this. Okay, and then we put this one here and this one here and this one back over here and this one here. Oh, nice. This is an interesting problem. I need to think about this. I'm muting my mic and let me think. Yeah, what I was saying, my mic was mute, right? This is a very nice problem. This needs a lot of thinking into it. So, just for a moment, I'm switching on to the next question in case if it can be solved easily. Creating strings. Given a string, your task is to generate all different strings that can be created using its characters. Okay, 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 okay. You need to ding, ding, ding. Okay, 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 okay. I got it. Repeated characters. That's repeated characters is the trick, man. Come on. Mm-hmm. It's okay. Questions. Tough. You need to get. A we have three. B we have one. C we have one. So now we mm, number of permutations in factorial y 5 factorial y 3 factorial 5 or 3 2 1. Yeah, we can get the answer, but how to generate these? Mm-hmm. You need to think about these questions. Maybe I just need a little break because my brain's not training. Hello, I'm back. Yeah, let's continue with our two problems. Okay, strings. Okay. This is tough. I feel like sleeping. Seriously. But we need to think. We need to think. What's on my plate today? Mm, see, the problems that you get like this are not the ones that increase your knowledge. The problems that make you think are the ones that increase your knowledge. So, yeah, these are the ones that you need to think about. So, today on my plate are these three problems: two nights, Tower of an Eye, reading strings. Wow, if we complete this, we will have nine more. It took him five years, man. Of course, CP enthusiast. Well, let's see our profile, na? Oh, he's all 27. Huh? Nice, Ray. Let's complete CSS. Is there no in Codolio? There is no CSS one, no. How to add CSS in this? Chalo, bye. My brain's not braining, man. Okay. A all एक चिंक, B all एक चिंक, C all एक चिंक. Insert function we can use now. Set strings. Set of strings, man. Okay. మా మ్హూ. let's go. I was so afraid of this question before, thinking I might not be able to solve it. But yeah, as I went through it, I understood at any starting point, if there is a occurrence of A for three times, we should not take three helper functions like the helper function that I was using. If there is even three occurrences, you take only one helper function because all will give the same ones, right? Yeah, that's one thing. Backtracking and recursion. So this question is based on it. I was so afraid of this question, but yeah, I was able to solve it. Let's go, guys. Don't be afraid of questions. You will be able to solve it. Take a solid break before so that your mind will be fresh. Okay. Yeah, let's go. This how. Yeah, let's no ding ding ding. Let's not hide this panel. Yeah, let's hide this panel. Let's hide this panel also. Yeah, that's it. How to? Acha. Okay. Okay. This looks like TLA eliminators ones now. Okay. TLA eliminator screen also that will be like this only. You remember? Yeah, this is fancy. Wow, this is fancy. It's okay. Mm. Now, Tower of Hanoi. Now we have Tower of Hanoi. Hmm. And this two nights question also. Don't be afraid of the questions, guys. The only thing I have learned. Dry run questions. Manually do it, then you'll get it. Left, middle, right. Again, laptop's charged. No, no, what? How to do it? You first minimize these pakkan madeste. How to find a solution? Let's do this. Finding a solution. I'm afraid of this question. What to do? What to do? Don't overcomplicate things. Don't be afraid of the question. Even if you don't get the question, it's okay. It's okay. Just go solve it, man. Sorry, oh man. Let's mute this mic, okay? now I got this in mind. For that, first we need to get the largest pile to the rightmost one and all the remaining pile to the middle one. So that's what we need to do it. So, um, largest pile here, the remaining pile here. We need to recurse on this. This being the last one and this the middle one. And then this remaining pile, how you shift. That's another thing now. How you shift. Oh, this is tougher. I need a lot of time for this. That won't be completed in life. I'll take my time. Today, I'll take my time, solve these two questions, and I'll come tomorrow and see how I solve these. Okay? Bye. Because I need time now. One problem that I asked now, I should cry for that problem. That problem came. But I'll solve. Okay? Bye bye. Hey, by the way, my English is good. You can't always speak that nice English now. That's just my funny way of talking to myself. Okay, bye. Anyway.